Hey everyone, welcome to another episode of Black Guy Does Physics. Today we're going to be looking at a problem from a test number 2, problem 2, that I gave my students today. Now, if there's any physics problem that you want this black guy to solve, please just comment below. Okay, let's get it cracking. First things first, I want to look at the diagram that I have. The reason why I want to look at the diagram is that I want to upload the concepts that I already know. Okay, bring them to the front of my brain. When I look at this diagram, I see that there's a radius. So automatically, the first thing that pops to my head is centripetal forces. Automatic. The reason why it's centripetal forces is because that's the only one that has radius in it, man. Now, so I write that down, FC for centripetal forces. The next thing I see is a vertical displacement, aka a height. So automatically, the first thing that pops up in my head, energy. Sweet energy, I write that down. This looks like a skier is moving, so I could put motion. However, you always want to know that if you could use energy instead of motion, always use energy. Don't mess around with motion if you don't have to. Energy all day, every day. All right. Now that we have uploaded all this stuff in our brain, now let's tackle this problem. A 61 kilogram skier, so I go ahead and I underline a 61 kilogram skier, and that would be my mass, so that would be m is equals to 61 kilogram, encounters a dip in the snow surface that has a circular cross-section with a radius of curvature of 12 meters. So radius of curvature, that's just r. R is equals to 12 meters. If the skier's speed at point A, so let's underline right there, that would be my initial speed. So my initial speed would be 8.0 meters per second. What is the normal force exerted by the snow on the skier at point B? Normal force, I use the symbol F subscript N for normal force. So ignore frictional forces. So I underline that to make sure I understand there are no frictional forces. Great. Now, we're good now because the question is telling us explicitly which concept to start with. Whenever you have multiple concept problems, like in this case where you have centripetal force and energy, you have to choose which one you want to start with. You could start with any one, but the one you want to start with, it's the one that problem is asking you about for. So in this particular case, that would be centripetal forces. For every single concept, every single time, what you need to do first is just simply write what is true. So what is true for centripetal forces? That is the F net radial is equals to mv squared over r. Great. Now, if I'm going to use this, I have to know where the skier is going to be and when I want to find the normal force. Now that would be at the bottom here. So I'm going to draw me a nice little box for the skier. And then I'm going to draw my forces. The reason why I'm drawing forces is because this is F net radial. So you have to draw forces. So I have going up is my normal force, which is perpendicular to the surface. Going down, straight down, which is my weight. And then I just add these. Remember, they're acting along the radial line because they're both perpendicular to the surface right there. So I add them. And that would be Fn minus mg is equal to mv squared over r. At this particular point in time, I could check to see which variables I have. I could just check, and if I check, I could see that I have mass, g, m, and r. So the only thing missing is v, and if I could find v, then I could find Fn. Now, at this particular juncture, you don't want to panic, man. That's the worst thing you could do. You could panic. Do not panic. Lots of my students, they panic right here. Do not panic. Why don't you panic? Well, you already use the centripetal forces as a concept. You have another concept, which is energy. So you just trust the process. Always trust the process. So the process is you just go and you look at the different concepts and write what is true. So the next concept here is energy. So what is true for energy? What is true for energy is E0 is equals E. That is, the initial energy is equal to the final energy, which simply means that the energy is conserved. For explanatory reasons, I'm going to write this long equation that I give my students. They hate it, but it's good. You don't have to write it out if you could just check for yourself, but I like to write it out. And that is my potentials, which is my gravitational and my spring potential, plus my kinetics, which is my translational and my rotational kinetics, plus the work which is done by any non-conservative force is equal to a constant. It's not changing. Now, if you want to use this, there are rules to it. It's the same concept where if you're looking at FNet radial, there are rules to it. You have to draw a force diagram for FNet radial. If you want to use the energy, then there are rules. First things first, you have to know where your initial and your final position is. So this one is kind of straightforward due to the fact that they tell you he starts at point A, so that would be my initial, and we're looking at point B, so that would be my final. The next thing I want to do is that I want to draw my y is equal to 0, aka my reference point. The reference point you want to put at the bottom. Why do you want to put it at the bottom? So that everything now becomes positive and you don't have to worry about no stupid negative signs, man. So you just put it at the bottom, and that is my y is equal to 0. Great. Once you have done that, then you're ready to use this thing. All you do is that you just check. You just check to see what types of energy you have initially and at the final position. So let's go at initial at point A. So you're above your y is equal to 0. Therefore, you have some gravitational potential energy. The equation for gravitational potential energy is mgh. The sphere is not a spring, so ain't no springs there, so you're good to go. The sphere is moving, so that's some translational, which is half mv0 squared. He's definitely not rolling, because if he was rolling, that would be a bad look. So he's not, it doesn't have any rotational kinetic energy. And they told you to ignore frictional forces, so no work done by non-conservative forces. Now we move to the final position, which is point B. For point B, my y is equal to 0. Therefore, if my y is equal to 0 at point B, that means I have no gravitational potential energy. The dude is still not a spring, so nah, but he's still moving. So therefore, he must have some translational kinetic energy, which is just half mv squared. Still not rolling. So therefore, if he's not rolling, no KER, still no friction. So that's that. Here, that is true. And you keep it moving. Now comes your mathematical skills. First things first, I could cancel out m's. The reason why I could cancel out m's is because m is in every term being multiplied. See? If it was just m in one or two terms, you don't want to do that. But since it's in every term, it's just multiplied. You could just cancel it out. Therefore, I could solve for v squared. Now you'll be tempted to solve for v and then square it, but that makes no sense. Why? Because you're looking for v squared. V squared is missing. So that means my life is nice and sweet. So I just multiply both sides by 2. That gives me 2gh plus v0 squared. So my v squared is equal to 2gh plus v0 squared. What do I do with that info? I take it and I simply just insert it back here, aka substitute. Or some of my students say, substitute. Don't know what that means. When you figure it out, you let me know. All right, and if I substitute that there, what you'll have is that you'll have Fn minus mg is equals to m parentheses 2gh plus v0 squared, close parentheses. And then I rearrange for Fn. Fn is equal to m parentheses 2gh plus v0 squared plus mg. At this point, if you want, you could try and further factorize this down, but why bother when you have all this information? Meaning that you have mass, you have r. Oh, I left my r out. Look at me, being a moo-moo. Don't be a moo-moo, kids. All right, there goes my r. And, oh, that looks hideous. Let's erase this. That's why you always take it slow. You do not rush. See, I left my r out. Great. Now I could write Fn m 2gh plus v0 squared over r plus mg. I have m, I have g, I have h, I have v0, I have r, and I have g. Therefore, all you need to do is just solve for Fn. Plug the numbers in and solve. Well, that's it for today. Another problem smashed. Like, subscribe, comment below, tell a friend, and kids, do remember, don't be a momo.